Welcome back, everyone, to the deep dive. Today we're going deep on something that's uh, super fundamental to anyone working with data,
Oh, yeah, good.
database performance. And, we're going to zero in specifically on these things called indexes and how to really make your SQL queries lightning fast.
Right.
Our source material this time is this Complete SQL Masterclass course.
Mm,
We're going to try to distill it down into something practical that you can take away and use.
absolutely.
So think of this deep dive as unlocking the secrets to a database that just hums.
Right. And really anyone who's worked with databases of,
Yes.
any reasonable size or scale knows that performance is not just a nice to have.
Yeah,
It is fundamental to how well your applications run.
for sure.
A slow database creates bottlenecks everywhere.
Right.
So let's jump right in with this concept of indexes.
Yeah.
Like, what are these things? Why are they so important?
Okay, so think about this for a second. Let's say you have a massive encyclopedia
Okay.
and you're trying to find one specific fact. If there's no index in that encyclopedia, you're going to be flipping through pages for hours. You're going to have to read everything to find that one little nugget.
Right.
And that is basically what happens in a database when you don't have indexes.
Absolutely.
The database engine has to do something called a full table scan. It has to look at every single row in the table to find the data that matches your query.
Yeah.
And, for small data sets, that's manageable. But as your database grows, this becomes incredibly slow,
Right.
really resource intensive. It eats up your CPU, it eats up your memory, it eats up your disk I/O. It's just a bad scene.
And not just that, it impacts the user experience, right?
Yeah,
Because if your database is slow, your application is slow.
totally.
And your users are going to get frustrated and they're going to leave.
Yeah.
So yeah, it's a big deal.
Yeah, so indexes are like this magic solution to that problem.
They are.
It's like having that perfect index in your massive encyclopedia. You can quickly go to the exact volume and the exact page number based on some keyword. And that's what an index does in a database.
Exactly. It's like a shortcut.
Yeah,
It's like a map that tells the database exactly where to go to find the data it's looking for
right.
without having to search through everything. And there are different types of indexes, different ways to create these maps.
Right.
One common way is to use something called a B tree, which is like a tree-like structure that allows for very efficient searching.
Okay.
Another way is to use a hash structure, which is really good for finding exact matches.
Okay, so let's say we want to create an index in SQL. What does that look like? How do we actually do that?
Well, the command's actually quite straightforward.
Yeah.
It's a create index statement.
Okay.
So for example, if we have a table called employees and we want to speed up searches based on the employee's name,
Mm.
we would write something like this. Create index, eDIG's employee name, and employees.
Okay, and that's it. That creates the index.
That's it.
And the database starts using it right away.
Well, it depends on the database system.
Okay.
But generally, yes, the database will start using the index as soon as it's created.
Okay.
And what it does is it basically takes all the names in that name column and it builds this sorted list of them.
Okay.
And it includes pointers to where those names actually exist in the full data.
Right.
So when you run a query later on that says, hey, find me all employees named John, the database can very quickly look up John in that index and go straight to the relevant rows.
Instead of scanning the entire table.
Exactly. And that can save a lot of time, especially if your table has millions of rows.
All right, now here's a crucial point. This is where things get a little bit more nuanced. While indexes are amazing for making those select queries super fast, those are the queries that retrieve data. They do come with a little bit of a cost.
Right.
They can actually slow down operations that modify data.
Yes.
So think about insert, update, delete.
Right, because every time you add a new row, or you change a row, or you delete a row, the database has to update not just the main table.
Right.
It also has to update all the indexes that are associated with that table.
Right, to keep them in sync.
Exactly. So it's not simply a case of the more indexes, the better.
Right.
You have to be strategic. You have to
Yeah.
be thoughtful about which columns you index.
Right. You have to think about the trade-off.
Absolutely. If you're doing a lot of inserts, updates, and deletes, and you have a ton of indexes, that can actually slow down your write performance quite a bit.
Okay, so we've talked about what indexes are and why they're important. We've even seen how to create one. Now let's get into the different flavors of indexes.
Right. Just like there are different ways to index a book, by subject, by author, by title SQL, offers different types of indexes, each designed to speed up different kinds of queries.
Okay, so first off, we have the single column index. This one's pretty self-explanatory. It's an index on a single column, like the one we just saw. create index employee name on employees. So that's a single column index.
Yep. And those are very effective for queries that filter or sort based on just that one column.
Okay. Then we have composite indexes.
Ah, yes. Composite indexes.
And these become really powerful when you have queries that involve multiple columns.
Right.
So let's say you often search for employees based on their name and indeed their department. A composite index on those two columns would be super helpful. Something like this. Create index its employee name department on employees.
Yeah.
Name department.
Exactly. So with that composite index, if you want to find all the employees named Jane Doe who work in the sales department, the database can use that single index to narrow down the search very quickly.
Okay, so it can use both criteria at the same time.
Exactly. Much more efficient than having two separate single column indexes.
Got it.
And the order of the columns in the index matters.
Well,
Yeah, it's a good practice to put the columns that are most frequently used in your queries, especially in your where clause, first in the index definition.
interesting. So if you filter more often by department than by name.
Then you want to create the index on department name rather than name department.
Okay, that makes sense. Makes the index more versatile.
Exactly.
Okay, what else? What other flavors of indexes are there?
All right, so we have unique indexes.
Okay.
And these are a bit different because they're not just about speed.
Oh.
They're also about data integrity.
Okay.
A unique index guarantees that all the values in that column, or combination of columns if it's a composite unique index, are unique. There are no duplicates allowed.
So things like employee IDs, email addresses.
Exactly. You wouldn't want two employees with the same ID or the same email, right?
Right.
So the command for that would look something like this. Create unique index,
Hey.
Dan's employee email on employees email.
Okay, and if you try to insert a new employee with an email that already exists.
The database will reject it. Throw an error.
Right, because of that unique index constraint.
Precisely. It's a way to enforce those business rules at the database level.
Okay, now let's talk about clustered and non-clustered indexes.
All right. These are a bit more about how the data is physically organized on disk.
Okay.
A clustered index actually defines the physical order of the data rows in the table.
So it's not just an index, it's like the actual order of the data?
Exactly. Think of it like a physical phone book where the entries are sorted by last name.
Okay, so like if you have a clustered index on employee.
Then the data rows on disk will be physically arranged in ascending order of employee ID.
And you can only have one clustered index per table, right?
Exactly. There can only be one physical ordering of the data.
Okay, that makes sense. What about non-clustered indexes then?
So a non-clustered index is a separate structure from the actual data rows.
Okay.
It contains the index columns and a pointer to the location of the corresponding row in the main table.
Kind of like the index at the back of a book.
Exactly. It tells you where to find the information, but it doesn't change the order of the pages in the book itself.
Okay, and you can have multiple non-clustered indexes on a table.
That's right. You can have as many as you need.
So just to recap a practical tip here, if you often run queries that filter or sort by a certain set of columns,
A composite index on those columns can really be your best friend.
right, it can really make those queries scream.
And in some cases, a well-designed composite index can actually satisfy the entire query from the index itself without even needing to access the main table.
Whoa, really?
Yeah, that's called a covering index.
Okay.
It's very efficient.
So we've covered a lot about indexes, but just having indexes isn't the whole story, right? We also need to think about how we write our queries.
Oh, absolutely.
Yeah.
Having indexes is like having a beautifully organized library.
Okay.
But if you go in there and you don't know how to use the card catalog, you're still going to have trouble finding what you need.
So we need to be smart about how we use these indexes.
Exactly.
So what are some of the key things to keep in mind when writing efficient SQL queries?
Well, first of all, make sure you create indexes on columns that are frequently used in your where clauses, in your join conditions, and in your order by clauses.
Okay.
But don't go crazy and index every single column because remember, there's that trade-off.
Right. Too many indexes can hurt write performance.
Exactly.
Okay, what else?
Another big one is to resist the urge to use select may.
What do you mean?
I mean, instead of selecting all the columns from a table, be specific about which columns you actually need.
Okay.
So instead of writing select from employees, if you only need the name and the department, write select name, department from employees.
Because that reduces the amount of data that needs to be processed, right?
Exactly. The database has to read less data from disk, transfer less data over the network, and process less data overall. It's much more efficient.
That makes sense. And what about when we're joining tables?
Ah, joins.
Yeah.
Make sure you have indexes on the columns you're joining on. So for instance, if you have a query that joins the employees table and the orders table on the employed column, you would want to make sure that both employees.employed
Right.
and orders.employed are indexed.
Okay, otherwise the database might have to do a lot of extra work to find the matching rows.
Exactly. And that can really slow things down.
What if you're dealing with a query that returns a huge amount of data?
That's where the limit and offset clauses come in handy.
Oh yeah, those are good ones.
They let you control how many rows are returned and where in the result set to start retrieving from.
So if you only need the first 10 results, you can use limit 10.
Exactly. And if you want to implement pagination, you can use limit in combination with offset.
Okay, so like for a web application where you only want to show 10 results per page, you could use something like limit 10 offset 20 to get the second page of results.
That's right. It's much more efficient than retrieving all the data and then throwing most of it away.
Right. And what about subqueries?
Subqueries can be tricky. They can sometimes make your SQL code more readable, but they can also hurt performance if you're not careful.
How so?
Well, it depends on the specific database and how it optimizes queries.
Okay.
But in some cases, rewriting a subquery as a join or using a window function can result in a more efficient query plan.
So it's worth exploring those options if you have a slow query that involves subqueries.
Absolutely.
Okay, now this is something I find super interesting. It's called query execution plans.
Yes, the execution plan. It's like looking under the hood of the database.
Exactly.
It tells you exactly how the database is going to execute your query,
Right.
what indexes it's going to use, how it's going to access the data, all the different steps involved.
So how do we actually see this execution plan?
Most databases have commands like explain or explain analyze.
Okay.
You just put that in front of your SQL query and it'll show you the plan.
So like explain select from employees where department it's sales.
Exactly.
And that will show you the steps that the database will take to execute that query.
Yep. And it can be super helpful for troubleshooting slow queries and figuring out where the bottlenecks are.
Okay, and last but not least, this is a big one. Testing.
Oh, yes, testing. Can't emphasize that enough.
Always test your queries on a non-production environment before you let them loose on your live database.
Absolutely.
Yeah.
You don't want to discover a performance issue in production where it can impact your users.
Right. A query that runs fine on a small test data set might behave very differently on a large production database.
Exactly. So test, test, test.
All right, so we've laid out a lot of theory, best practices, all that good stuff. Now let's bring it all together with a real-world scenario.
Okay, I like it.
Imagine we're running the database for a busy e-commerce store.
All right, a classic example. High volume, lots of data, performance is critical.
Exactly. So one very common thing is customers searching for products by name.
Right.
To make those searches super fast, you'd want to have an index on the product name column.
Absolutely. That's a no-brainer.
So something like create IDEX product name on product name.
Perfect.
Yeah.
Now, what about a slightly more complex scenario, like finding the top 10 best-selling products?
Okay.
You might write a query that looks something like this. Select product name, ESM sales, as total sales from products grouped by product name, order by total sales, DESC limit 10.
Right.
So in this case, you'd probably want an index on product name to help with the grouping.
Okay.
But you might also want to consider an index on sales to help with the sorting.
Because we're sorting by total sales, which is calculated on the fly.
Exactly. And as always, you'd want to use explain to analyze the execution plan and see how the database is actually using those indexes.
So explain select product name, SEM sales, as
Yeah.
total sales from products grouped by product name, order by total sales, DESC limit 10.
Exactly. That'll give you a much deeper understanding of what's going on under the hood and whether there are any other optimizations you could make.
So these examples really show how these concepts can be applied in the real world. It's not just abstract stuff.
Right. It's about making your e-commerce store run faster, respond to customer queries more quickly,
Yeah.
process orders more efficiently.
Yeah. And ultimately improve the user experience.
Absolutely. Happy customers, happy business.
Now let's shift gears a little bit and think about job interviews.
Okay.
These topics, indexes, query optimization, they come up all the time in technical interviews.
Oh, yeah, for sure.
So let's walk through some common interview questions.
All right, let's do it. Fire away.
Okay, first one. What is an index and how does it improve performance?
So an index is basically like a lookup table that the database can use to find rows in a table quickly without having to scan the entire table.
Okay.
It's like having a sorted index at the back of a book.
You're right.
It makes finding specific information much faster.
Okay, next question. What's the difference between a clustered and a non-clustered index?
So a clustered index actually determines the physical order of the data rows in the table. It's like the pages in a book. You can only have one clustered index per table. A non-clustered index, on the other hand, is like a separate index at the back of the book. It doesn't change the order of the pages. It just provides a way to quickly find specific information. And you can have multiple non-clustered indexes on a table.
Okay, how do you create an index in SQL?
The command is create index, index name on table name, column name 1, column name 2.
Okay.
You can specify one or more columns to create a single column index or a composite index. You can also use the unique keyword to create a unique index.
Okay, what is a composite index and when would you use one?
A composite index is an index on 2 or more columns. It's useful when your queries frequently filter or sort by those columns together. It allows the database to use a single index to satisfy multiple criteria.
Okay, how do you optimize a slow SQL query?
There are many techniques, but some of the most common include adding indexes to the columns used in the where, join, and order by clauses, avoiding select ticks, and being selective about the columns you retrieve, rewriting subqueries as joins, or using window functions, and using tools like explain to analyze the query execution plan and identify bottlenecks.
Okay, what is the purpose of the explain statement?
The explain statement shows you the execution plan that the database will use to execute your query.
Okay.
It tells you what indexes it will use, how it will access the data, and all the different steps involved. It's very helpful for understanding query performance and identifying areas for optimization.
Okay, how do you avoid over-indexing?
Don't create indexes on every single column.
Okay.
Only index columns that are frequently used in query conditions or joins.
Okay.
And regularly review your existing indexes to see if they're still being used. If an index is rarely used, it might be a good candidate for removal.
Okay, what's the difference between a unique index and a primary key?
Both enforce uniqueness. But a primary key also implicitly says that the column cannot be null.
Oh, okay.
And it typically serves as the main identifier for rows in the table.
So a table can have multiple unique indexes, but only one primary key.
Exactly.
Okay, how do you drop an index in SQL?
The command is drop index name on index, table name.
Okay, what is a covering index?
A covering index is a special type of index that includes all the columns needed to satisfy a query directly within the index structure.
Okay.
If a query can retrieve all the data it needs from the index alone, without having to access the actual table rows, it could be super efficient.
Okay, how do you optimize a query with a subquery?
Often, you can rewrite the subquery as a join or use a window function instead.
Okay.
Analyzing the query execution plan can help you determine if the subquery is a bottleneck and whether these alternatives might be more efficient.
Okay, what's the difference between a full table scan and an index scan?
A full table scan means the database has to read every single row in the table to find the data it's looking for. An index scan uses an index to quickly locate the relevant rows, which is much faster, especially for large tables.
How do you optimize a query with a group BYY clause?
Make sure the columns you're grouping by are indexed,
Okay.
and only select the columns you need in your select clause.
Okay, what's the purpose of the limit clause?
Limit lets you restrict the number of rows returned by a query.
Okay.
It's useful for pagination, for retrieving only the top end results, and for improving performance when you only need a subset of the data.
And finally, how do you optimize a query with a join?
Make sure the columns you're joining on are indexed.
Okay.
Be mindful of the type of join you're using and make sure it's the right one for your needs.
Right.
And avoid accidental Cartesian products, which can really kill performance.
Okay, let's wrap up with a couple of scenario-based challenges.
Right, let's put our knowledge to the test.
So imagine you have a query that filters employees by department and then sorts them by salary. How would you create an index to speed that up?
Create a composite index on department and salary. Something like create index X department salary on employees.
Right.
Department salary.
Okay, and what if you have a query that retrieves the top 10 highest paid employees? How would you optimize that?
First, make sure you only select the columns you need.
Right, no selecting me.
Exactly. And second, Make sure there's an index on the salary column.
Okay, so that's it for our deep dive into database indexes and query optimization.
I hope you found it helpful.
Yeah, me too. These concepts are really crucial for anyone working with data.
They can make a huge difference in the performance of your applications.
Next time on the deep dive, we're going to be talking about transactions and concurrency control.
Ooh, that's a good one. We'll be exploring how databases handle multiple operations happening at the same time while ensuring data integrity.
It's a fascinating topic. And as always, if you have any questions or suggestions for future deep dives, please let us know.
We love hearing from you.
Okay, so here's a final thought. Mastering the art of querying your data efficiently is like unlocking a whole new level of insight and potential.
It's true.
So keep learning, keep exploring, and happy querying.